This is Jutech Academy. In today's presentation, want to see the differences between petrol engine and diesel engine. On our chart here, what we have is the petrol engine, Otto Cycle, diesel engine, Diesel Cycle. The Otto Cycle is an idealized thermodynamic process that is used to describe the working of petrol engine. As you can see in our chart here, on the vertical axis is the pressure, on the horizontal is the volume, which is pressure volume diagram. We have TDC here and we have BDC here. TDC is the highest distance traveled by the piston in a stroke, and BDC is the bottom dead center, the lowest distance traveled by the piston. This one is top dead center. When the piston moves from 1 to 2 to this point 0, or from 0 to 1, it has covered a stroke. So let us see what happened. Both petrol engine and diesel engine undergoes the same processes. The same processes as in 4 processes that occurs in a cycle. And these 4 processes are suction stroke, compression stroke, power stroke, and the exhaust stroke. They all occur in the same in both engine, but let us note the differences. Let us start by describing the Otto Cycle. As the piston moves from TDC to BDC, 0 here to 1, the suction stroke, it sucks air from atmosphere. During suction stroke, the volume increases. The piston travels from TDC to BDC, the volume increases. It admits mixture of air and fuel that has been mixed either in the carburetor. Now, as it gets to point 1, it will travel back to TDC again. As it travels back to TDC, it compresses back this mixture of fuel and air. As it's compressing it, the pressure increases. That is why you see this elevation, this increment. The pressure increases to point 2, and you see reduction in volume. It travels back to TDC. You can see, but the pressure increases. See the level of the pressure. It's no longer here. It has increased. Now this point 2 to 1 to 3 is what we call heat addition. As you can see, it's indicated with red. Heat addition. At this heat addition, spark plug comes into play, where spark plug will initiate spark into the mixture of fuel and air, and it will ignite. And this heat addition occurs at constant volume. We call it an acyclic process, constant volume, and we call this process 1 and 2 isentropic process. There is no transfer of heat or mass of the substance in or across the system. From stage 2 to 3 is the heat addition, ignition of the fuel, air mixture. And as ignite, you will see at constant volume, but the pressure will increase because as the heat is added, the combustion takes place, the mixture gains more kinetic energy and the pressure increases more. That pressure pushes down the piston from stage 3 to stage 4, and we call it power stroke. Power stroke also occurs on asymptotic process, adiabatic asymptotic process. there is no flow of heat or mass of the substance in or across the system. So you can see that the pressure drops as it expands. Then at this stage 4 to 1 is another isochloric process, the same process that occurs here but in reverse. This one is heat removal, this one is heat addition, this one is heat removal. Heat removal makes us to understand that there is what we call ignition timing. Ignition has a time to occur, doesn't occur at all time in the internal combustion engine. So at this point is heat removal. Ignition occurs here, ignition was removed here, and from here that heat removal occurs at a constant volume. There is no increase in volume nor decrease in volume. So but there is decrease in pressure because heat has been removed. The kinetic energy of the system drops, reduces. Now from point 1 again to point 2 is exhausting of burnt gases to the atmosphere. This is exactly the working of Otto Cycle. Let us look at the Diesel Cycle. Both has the same PV, they are being explained on the same PV diagram. They both have TDC and BDC as we explained before. Now as the piston travels from TDC to BDC, what happened? It sources only air. Instead of air and fuel mixture, it sources only air. And as the piston moves from stage 1 to 2, it compresses this air to a very little space. It compresses this air to a very little space. At this point 2 to 3 is heat addition. How is heat being added? Injector, instead of spark plug, atomizes diesel fuel into the system and it ignites. What ignites it? The heat of the air that has been compressed will ignite the fuel that is being atomized, and combustion will take place. And this happens at constant pressure. As you can see, there's no increase in pressure, neither decrease in pressure. Rather, there is slight increase in volume. There's slight increase in volume because of the delay in ignition. That is ignition delay. You can see. So this happens in what we call isobaric process. You see the difference? At this point, it is the injector that atomizes fuel, and the ignition occurs by the heat of the air that was compressed, and it occurs at a constant pressure. But in petrol engine, it occurs at a constant volume, and it is the spark plug that ignites the fuel, and it is the fuel and air mixture that was taken in. You see, let us be noting the differences. We'll be noting down the differences, and as the mixture is being ignited here, there will be gain in kinetic energy, and the pressure, the charge pushes down the piston. That is the power stroke expansion. It expands. As it expands from stage 3 to stage 4, you see the volume, the increment in volume and reduction in pressure. Then from stage 4 to stage 1 is the same constant volume heat removal. Constant volume heat removal here in Otto Cycle, the same constant volume heat removal. That is isochloric process. The same isochloric process occurs here. Here is isobaric process. Here is isochloric process, heat addition. So Here is the same isentropic process. Now, this heat remover from stage 4 to stage 1, heat is removed. Then from stage 1 also to stage 4 is exhausted. The burnt gases are being exhausted to the atmosphere. And that this is the description of these two processes. So I would like us to visualize this in a practical approach. This is a simple illustration, simple diagram to illustrate a typical reciprocating engine. This is crankshaft and this is the connecting rod. This is the piston, and as you can see, this is the cylinder. This is the cylinder. This is the cylinder block. Now, and this is exhaust valve. This is inlet valve. This is position for the spark plug for petrol engine, and also position for injector for diesel engine, as you can see. Now, this part, I want us to note the meaning of this part, because it will be required when we will get to another stage where we will talk about compression ratio, because compression ratio is the volume, total volume of the cylinder all over the clearance volume. Total volume of the cylinder is the swept volume, distance from here to here, swept volume plus the clearance volume. Clearance volume is that of the combustion chamber. That's the clearance volume. As you can see, when we explain the TDC and BDC on the graph, this is BDC, the lowest distance as traveled by the piston, and this is TDC, highest distance traveled by the piston. As we start the machine, you see, this is it get to here and it comes down. You get to here, it comes down. In the reciprocating motion, you get to here and it comes down. And from here to here is what we call swept volume, the volume swept by the piston. And from here to here is the clearance volume, where the combustion, as you can see, combustion is taking place. As you can see, where the combustion takes place. As you can see. And this is where the gas is being compressed. So in calculating the compression ratio CP, compression ratio is the total volume, swept volume plus clearance volume all over clearance volume. That is what we use to determine the compression ratio of an engine. Let us look at other illustrations that describes more the differences. Diesel engine uses diesel as fuel, and petrol engine uses petrol as what? Fuel. Diesel engine is described in Diesel Cycle, and petrol engine is described in Otto Cycle. Diesel engine is compression ignition and uses injector. Petrol engine is spark ignition and uses spark plug to initiate spark. Thermal efficiency of diesel engine is between 40% to 45%. What do we understand by thermal efficiency? Thermal efficiency is the ability of the diesel engine to convert the heat energy to mechanical energy. So the heat energy that is supplied to the machine, 40% to 45% of it is being converted to mechanical energy that is used to perform mechanical job. Thermal efficiency of petrol engine is between 25 to 30. As you can see, that of the diesel engine is higher. During such short stroke, In diesel engine, only air enters into the cylinder. During suction stroke in petrol engine, both air-fuel mixture enters into the cylinder. Diesel engine uses injector pump to force fuel into the cylinder through the injector. In petrol engine, carburetor is used to premix the air-fuel before entering the cylinder. Diesel engine has a higher compression ratio of about 11:1 to 20:1. What do you understand by compression ratio? I try to illustrate it on the animation that we did above. I said that compression ratio is the total volume of the cylinder divided by clearance volume. So compression ratio is the sweat volume. Some people may not really understand. So that is the total volume of the piston divided by the clearance volume. And the clearance volume is the volume that the charge is compressed, the highest volume that the charge is compressed. So diesel engine compresses the charge to a better smaller volume because it is only air that is being admitted into the cylinder and compressed. In case of fuel or petrol is more volatile and ignition occurs more faster because of volatility of the petrol fuel. So that is why the diesel engine has more compression ratio, because it compresses the air, only air, to a very little space. But that of petrol engine, because the liquid, it is in a liquid form mixed with the air and very volatile, it doesn't compress to that level before ignition occurs. So diesel engine has more compression ratio than that of petrol engine. Diesel burns more slower, thereby increasing more energy for more mileage. Then petrol burns more faster. That is why I say it's more volatile. Diesel fuel has more energy rating about 38.8 megajoules of energy per liter. Diesel fuel has energy rating of about has energy rating of about 34.8 megajoules of energy per liter. So as you can see that diesel fuel has more energy per liter than that of petrol. Diesel engine has more torque at low RPM and better mechanical advantage. Petrol engine has less torque at low RPM. Thank you for listening. Please, I would like you to click the like button, subscribe, and comment for more improvement.